guys, in this video we're going to learn how to take the second derivative using implicit differentiation. To reiterate, we need to find the second derivative in this problem. If you haven't checked out my previous videos of us taking the first derivative using implicit differentiation, I highly suggest that you watch that before proceeding with this problem. But jumping right in, first we'll find the first derivative, or dy dx. So we'll start by taking the derivative with respect to x of each of these three terms. The derivative of x cubed is 3x squared. The derivative of 4 is 0. And the derivative of y squared is 2y. But if we'll recall with implicit differentiation, when we're taking a derivative with respect to x of a y term, we must add the dy dx term here next to each y derivative. Because the next step here is isolating this dy dx to get our answer in the form of dy dx equals something. So what I would do to isolate this dy dx is move the 3x squared over to the other side. And then we're left with dividing each side by 2y to obtain our first derivative of the original problem statement as negative 3x squared over 2y. Now our task is to derive this problem one more time to obtain the second derivative of the original problem statement. So I'll just rewrite that over here. And we'll notice that this is a quotient rule problem. If you haven't checked out my quotient rule video, please take a look at that. I would start with defining u and v here. U is negative 3x squared, v is 2y, and then the derivative of u, du dx, is negative 6x. The derivative of v, or dv dx, equals 2. But this is implicit differentiation, and since we derived a y term, gotta remember to add the dy dx here. Going forward with the quotient rule, we first multiply v by du dx, which is 2y times negative 6x, minus u times dv dx, which is negative 3x squared times 2 dy dx, all over v squared, which is 2y squared. So I'll just simplify this down below. We have negative 12xy plus 6x squared dy dx all over 4y squared. I'm just going to rewrite this down here so all our work stays organized. And something to note with these problems is the derivative of the problem statement is typically the left side of the equal sign. These values are always going to be equal to 0, and this comes into play when we're isolating dy dx. Because if we didn't have this in the form of this derivative equals something, then it would be impossible to isolate dy dx. So the first thing I would do to isolate dy dx is multiply both sides by 4y squared, which just leaves us with negative 12xy plus 6x squared dy dx equals 0. So we can rewrite this as 12xy over 6x squared, and that simplifies down to 2y over x. And that's going to be our answer to the second derivative with respect to x using implicit differentiation. That's it for this video, guys. Hope this was helpful. Thank you so much for watching. Please like and subscribe if I taught you anything. And most importantly, good luck on your exams. Thanks again. Take care.